Okay, so the next part of our notes are going to be about intervals of increase and decrease. And I just want to take a second and remind you of slope. When we talked about slope way back when Algebra 1, we talked about the different types. And we had a positive slope and we had a negative slope. This is going to help us figure out when our function is increasing and when it's decreasing. A positive slope starts down here and then goes up or increases. So when we see a positive slope, we'll know our function is increasing. Likewise, when we have a negative slope, it's decreasing. So everywhere we have a negative slope, we're going to decrease. So look at our function that's graphed for us right here. Again, vertex tells us turning point. So here's my vertex, and it kind of splits my graph into two different parts so that they're symmetrical. This side is the same as this side. And that happens for us at -7. Right here, we split our graph into two different parts. On this side of the graph, we have an increasing function because our slope is positive. So from -infinity all the way to the -7, we're increasing. Now at -7, something happens and we change directions and we start decreasing. We start having a negative slope. So from -7 and then on forever and ever and ever in the other direction to positive infinity, we are decreasing. So when we talk about increase, we use intervals like we did for absolute values, inequalities when we solved them. So our increasing would be from -infinity to -7. And when we decrease from -7 to infinity because it just keeps going forever and ever. For example 3, which is on the back of your notes sheet of paper, the question asks us over what intervals the function is increasing and over what interval it's decreasing. So again, we're going to start by finding our vertex, which is our turning point, and our vertex is actually at 0, -7, and so where we turn is going to be at 0, right? Not really caring about y, but where x is. X is 0 here, so that's where we turn from decreasing on this side, because we have a negative slope. So from -infinity all the way to 0, we're decreasing. And on this side, from 0 off into the distance to infinity, we're increasing. So from 0 to infinity, that's where this function is increasing. The last example on your paper is to write everything you know about this function. Take everything we've talked about from the entire unit, and we're going to explore this function. You're going to do the same thing in the You Try Next. So what do we know about this function? Well, it opens upside down, which means it's a reflection. So if I was going to write the equation for this function, it would start with a negative number because it's a reflection. The other thing I notice is that it has a slope of 1/2. So not only is that number a negative number, it's a -1/2 because we have to go down 1/2. It's an absolute value function because it makes a V shape instead of a U shape. I also know that it's been shifted to the left 1, so that means x plus 1 inside my absolute value, and then up 7, which means I have a plus 7 on the outside of my absolute value. I also know the domain and range of this function. The domain is all real numbers, and my range is 7, everything less than that. So y is less than or equal to 7. I also know end behavior and intervals of increase and decrease. I'm increasing from -infinity all the way to -1, and then I'm decreasing everywhere from -1 to infinity.